So again, we're gonna review graphing lines. If you feel like you have a pretty good understanding still of graph lines, feel free to work ahead. If not, follow along. Just if you are working ahead, just make sure you're checking your answers to what I'm doing up here, so that you're doing it correctly. Again, we're going over this concept that we already talked about on Algebra 1. Because it is something you're going to see do a lot of in Algebra 2, so it's just good to review. And what we have in this box at the top is the equation of the line and slope intercept form, which is y equals mx plus b, where the m is the slope and the b is the y-intercept. Right? Those are the two things you need to know in order to graph a line. The y-intercept and the slope. And again, the m is the number in front of the x, and the b is just the number at the end by itself. Right? So we take a look at example 1. We're going to graph these lines. Again, nice little refresher. So first what you need to identify, you need to identify your m, and you need to identify your b. Okay? So we look at this. Which one is our m? Which one is our b? Adam, what's our m and what's our b in A? Okay. Very good. Our m is 2 over 3 and our b is 1. Which one do we always start at? Do we start with our slope or do we start with our y-intercept? Y-intercept, very good. And because we're starting on our y-intercept, do we start on the y-axis or do we start on the x-axis? Y-axis. We always start on the part that's going up and down. So what we're going to do, we're going to go to where y is 1, which is right there, and put a point. And then you just follow your slope. Your slope is positive 2 over 3. So that means which directions are we going to go, Izzy, if it's positive 2 over positive 3? We go up the top number, so we're going to go up 2. Then we go right the bottom number, 3. Up 2, right 3, up 2, right 3. We went up and right. Let's see what other direction can we go. Good. And down and left. So we go down 2, left 1, 2, 3. Down 2, left 1, 2, 3. Down 2, left 1, 2, 3. And then you just connect with a nice, neat, straight line. Let's go. Again, remember to actually graph that line. That's what I asked you. Don't just put the points and move on. Draw the line or you won't get full credit. Questions over that? Okay, we take a look at B again. Identify what's my M, what's my B. Riley, what's our M and our B?
The M is -1/2.
Good. Negative 1/2. Our B is negative 3. And then just like the last one, you always start with your y-intercept, which is our B. And you always start on the y-axis. So we're going to start on y is negative 3. This is down here. And then follow our slope, which is negative 1 over 2. Might go if our slope's negative 1 over 2, which direction are we going to go? Negative 1, we're going to go down. Good. And if it's positive 2, we're going to go left or right. Good. We're going to go down 1. Good. Right 2. 1, right 2, right 2, all the way across. You can't go anywhere. So we went down 1, right 2. Alyssa, what other direction can we go? Up 1. Good. Up 1. Up 2. Questions over that? Well, you might be noticing an example. Twos are not so easy. It's not written nice, neat for you in slope-intercept form. Okay? Sometimes this happens, and when this does, you must write the equation slope-intercept form by solving for y. If you notice, in all these, y was by itself, so you can easily graph it. In these examples, there's a bunch of other stuff with y. So what you have to do is solve for y, then graph the line. Okay? So in this first one, we want to get y by itself. Okay? In order to get y by itself, does anyone know our first step? Well, that's what we want to get it in. To get it in that, what do we need to do? Wanda? Good. You always want to move the x over first. In order to move the x over, it's a positive 6, so I like what Yolanda said. We're going to subtract it. To get 3y is equal to, again, we're putting it in the form y equals mx plus b. The x is first, so I'm going to write it first. I'm going to write negative 6x. And then tack on the number. It's a positive 18, so I just put plus 18. Because 18 and negative 6x are not like terms. That does not become 12x. It does not become 12. 18 minus 6x is 18 minus 6x, or negative 6x plus 18. They're not like terms. So we still have one more step to go to get y by itself. Blake, do you know what we need to do with this 3 to get y by itself? There you go, we're going to divide it. We're going to divide every single thing by that number in front of the y. Divide the x by 3, divide your b by 3, divide everything. That way y is by itself. Negative 6 divided by 3 is negative 2. And then 18 divided by 3 is 6. So then identify your m. And identify your b. We got y by itself. And what's our m and our b? Good? Perfect. And again, we always start at our b on the y-intercept. So we always start here. Here's the thing. Our slope's normally a fraction. And this time we only have a whole number. So what's that whole number technically over? A 1. That way it makes it a fraction. Remember when it goes a whole number, put it over 1. So now we can follow our slope. And again, it's negative 2. So we're going to go down 2 and then right 1. Down 2, right 1. Oh gosh. We went down 2, right 1. Becca, what other direction can we go? Down 2, right 1.
Up 2, left 1.
Perfect. Up 2, left 1. There you go. I got it. Okay, do the same thing. We gotta get y by itself. Alex, to get y by itself, what's our first step? Okay, we're gonna add 2x. We're subtracting it. Move that x over first. Y, and again, just stick that x right out in front first. And then if you have a negative 10, just tack it on at the end. They aren't like terms, so don't combine them. And then our very next step to get y by itself. Other Alex, what do we have to do with that 5? So I would say, good, very good. We're going to divide. Divide everything by 5. Get y is equal to this. 2 over 5 simplified as a fraction. No, leave it at 2 over 5. Don't write it as a decimal. Leave it as a fraction. And then 10 divided by 5 is gracious. Now you can grab it, just like we done the other one. Okay. Identify your M, identify your B. Haley, what's our M and our B? Always start with your B on the y-axis. So I'm going to start at -2, and then follow your slope. Up 2, right 5, up 2, right 5. And then go down 2, left 5, opposite direction. Down 2, left 5, and connect. Nice, neat straight line. And questions over that? Can we take a look at C again? We have to get y by itself. So, again, what's our first step to get y by itself? Move it over. Positive. We move it over. It turns negative. So we get -2y equals -4x plus 12. Again, stick that x out front. We still need to get y by itself. Taylor, what's our next step to get y by itself?
Divide 2.
Good. Divide by that -2. We're going to divide everything by -2. Get y is equal to -4 over -2. What does that simplify down to? Anyone? 2. Get 2x. And then 12 divided by 2 is -6. So there we go. And identify your M and your B. Alexis, what's our M and what's our B in this one? Our M is 2 and our B is -6. Again, always start on our y-axis and follow your slope. Again, we have a whole number. What are whole numbers? Do we always put those over? 1. That way you have a fraction. Everything that's 2 over 1. So then that's all positive. So we're going to go up 2, right 1, all the way across. Can't go anymore. We want up 2, right 1, we can go down 2, left 1, opposite direction. And connect. We are done. Questions? No. Okay. So, last one for this section, for this part of the note. We still need to get y by itself. We can't quite graph it yet. Tristan, what's our first step to get y by itself? Good. How are we going to move it? Good. Subtract x. Gone. We're left with 3y is equal to, again, stick that x right out in front. Tack that number on in the back. Still need to get x by itself. So Trinity, what do we need to do to get x by itself? And divide everything by that 3. That's kind of weird. We got x over 3. Okay, but technically, in order to get a fraction, what's in front of that x? -x over 3. What's in front of that x? A 1. That way we get our fraction. That's technically a -1 in front of that x. So we write as -1 over 3x. And then -6 divided by the pi. What do we remember today? -2. Everything has 2 in it. Slope for the y-intercept. So then when we graph, identify your M, identify your B. Josh, what's our M and our B? Good. What's our M? Perfect. And then we graph. Again, when we graph, always start at your B, where B is -2. And our slope's -1/3, so we just follow that slope, down 1, right 3. Or up 1, left 3. Questions over those 4, solving for y and graphing. Nope. Okay, this little last bit of the notes, we're going to talk about horizontal and vertical lines. We talked about how to graph these a little bit this year with transformations, especially with reflections. But we're going to just review them again. Important thing to know for Algebra 2. An example of a vertical line is going to be x equals 3. So it's x equals a number, and that's it. You're always going to have a vertical line every single time. Because how you graph them, you go to where x is 3, and that means that line you're drawing can only touch the x value of 3. No other x values. So if you go and draw a horizontal line, you're going through the entire x-axis. Which means you're touching every single x value. That's not what we want. Okay? We only want where x is 3. So you have to go the opposite way of what the axis is going. So you're going to go vertical. Okay? Another important thing to know is vertical lines have undefined slope. The reason is, when we find slope, rise over run. Okay? We do our rise, again, just pick 2 nice neat points, find the slope. I count up 1, 2, 3. Okay? But there's no run, because we already hit the point. We already hit the other point on that line. Normally when it's slanted, you have to count up and then over. There's no run because it's straight up and down. So that means our run is 0. Okay? And whenever you have 0 in the bottom of a... Whoop. What the heck? Where'd you go, baby? There you go. Whenever you have 0 in the bottom of a fraction, always undefined. So that's why vertical lines always have undefined slope. Okay? If we take a look at this next example, horizontal line. Horizontal line will y equals a number every single time. And there's no other variable. It's just y equals a number. Because sometimes you have y equals like 3x. That means the line's going to be slanted because there's an x in it. Okay? Y equals a number will always produce a horizontal line. Again, same reason. If you go to where y is -1 and you draw a vertical line, you're touching every single y value. We only want a line with a y value of -1, and that's it. So you have to go the opposite way, which is horizontal. The opposite of what the axis is. So x-axis, go opposite, so it's going to go towards vertical, and then opposite of going the y-axis is horizontal. And they have a slope of 0. Again, if we look at rise over run, pick 2 points. Okay, this point and this point. We have no run. They're already in line with each other. We don't have to count up or down, so our run 0, or rise, sorry, and then our run when we count is 3. And 0 divided by anything is 3. I talked about that a little bit this year. Big thing to remember is how to graph them. Okay. Questions over that? No. If we take a look here, to graph it, in A, we're graphing the line y equals 5. So we go to where y is 5, which is right here. Right here. And then we have to plot our line. Tristan, do you saw what we just talked about? Are we going to draw a horizontal line or a vertical line if it's y equals 5? Very good. Horizontal. Opposite of what the axis is. So it's y, go opposite. Horizontal. Good. And then the last one, x is -8. Oh, That's where y is -8. Well, where x is -8 is right there. And then Braxton, now we're going to draw a horizontal or vertical line. There you go, it's going to be vertical. Oh, nice. Neat vertical line. And Lord. Questions over any of that? No? Okay.